Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I am so excited to be here with you tonight. Before we get started, I always like to do a little get to know you. So before we get started, I always like to find out who's in the room. So in the comment box, let me know your name, where your name pops up when you log in. So let me know where you're from, what test you're prepping for, and what is the other question? I always like to do like a get to know you question. So, this is a good one. Do you think Teacher Appreciation Week should be celebrated this week or next week? If you are on social media, you know that it is a hot topic because National Teacher Day was yesterday, but like National Teacher Appreciation Week is next week. So why are they not in the same week? So which would you pick? Would you pick the first week of May or the second week of May? Our school is celebrating it not this week, but next week. So there's that. But anyways, your name, where are you from, what test are you prepping for, and when would you choose to celebrate Teacher Appreciation Week, this week or next week? Hey, Terry, good to see you. Also, I had a ton of requests for different types of problems for this week. And so I am going to go over those problems, and you'll notice that there's asterisks next to certain problems, and that means that is a problem or a problem type that was specifically requested. So if there's anything that you want to see me going over in the upcoming weeks, please let me know in the comment box. It really helps guide these sessions to be more beneficial for you. So if there's something that you want to see, let me know in the comment box, and I'm happy to include it in the upcoming sessions. Like I said, this week's is jam-packed full of specific requests that people had. So without further ado, let's go ahead and get started with our first problem. And I'm going to make a bet that we're going to get to 6:26 before my iPad disconnects. It's become a running joke around here. I feel like my iPad will not stay connected to this streaming platform, but it'll stay connected for anything else. So I'm going to say 6:26. That'll be our get to know you question next week. When do you think my iPad is going to disconnect? Hey, Susanna. Hey, Hope. Good to see you. And it's just so good to be with you guys. All right. First problem. Let me make my screen bigger. All right. This is a lengthy question. Hey, Joseph. Good to see you. This is a lengthy question. I'm texting Dr. A right now because I think there's a problem with the streaming platform. Mrs. Smith asked students to solve the problem 542 plus 398. Jason explains his reasoning below. Is Jason's reasoning justified or not mathematically justified? The answer is 840. Now, when you see italics, we know that this is Jason's answer. The answer is 840. First, I added 500 and 300 and got 800. Then I added 8 ones and 2 ones and got 10 ones. That told me that I could make a 10 out of the ones, which would leave me with no ones left over. Then I added 9 tens and 4 tens, plus the 1 extra 10 I had left over, which gave me 13 tens, which gives me 840. All right, is his reasoning justified? Yes or no? So here's what I do, and a lot of you requested student error analysis. So here's what I do when I'm looking at a student error. If I have the time, I'm going to solve the problem that they are presenting to me. And then I'm going to look to see if the student is correct or not correct, because that's going to help me really frame out my answer. So 542 plus 398. When I add those together, I do get 10. 9 plus 1 is 10, plus 4 is 14. 5, 6, 7, 8, 9. So I know that the answer is 940, and that took me 10, 20 seconds. So I know his reasoning is not justified because he did not get the correct answer. So why is his reasoning not justified? Is it B or is it C? Jason's reasoning is not justified. He should not start by adding the hundreds first. He should start by adding the ones first. All right. In our brains, that makes sense. But let's keep going, and this is why it's always important to keep reading. Jason's reasoning is not justified. He should have taken the 13 tens, and that really should say 14 tens. That's a typo on my part. He should have taken the 14 tens and regrouped 10 of them to create another 100. Why was Jason mathematically wrong? Because he did not regroup the 10 tens into 100. Is it efficient to add the hundreds first? No. However, that does not keep us from getting the, I did not mean to circle that. That does not keep us from getting the correct answer. Can we add the hundreds first? Yes, we can. Watch. Had he done it correctly, and this is really when you start to teach students addition using expanded form or using blocks, often kids will start with the hundreds, and it's not mathematically wrong. Watch what happens. If I do 500 plus 300, and then separately I do 40 plus 90, and then separately I do 2 plus 8, is that okay? Yes. Watch why. 800 plus 10 plus 130, or 13 tens. Now I see that I have an extra 100, so it's going to turn into 900 plus 30 plus 10, which equals 40. And I promise you that students will represent this in 1,000 different ways. Susanna, I don't want to get into like the nitty gritty. I'm so glad you said that. We always start to teach with the ones place. Here's the thing, and this is like a huge soapbox of mine. I was a primary math coach for years. Conceptually, allowing students to kind of explore mathematics, and by just throwing a problem at them and allowing them to build it and add with the blocks or whatever first, which is really where that that concrete picture abstract comes in. And that's a huge piece of these exams, is understanding the developmental understanding of mathematics. And that's for everybody. Understanding that we really have to hone in on concrete understanding of mathematics, which means using manipulatives and really understanding what that math is represented by, then moving to pictures, and then moving to the abstract representation, which is what I just did on this slide. By allowing students to explore, you will notice that students might start by adding the hundreds first. And that's okay, because we want them to realize why it's easier to add the ones first. And I guarantee you 1,000 people that watch this video are going to think the same thing. So that's why that answer choice was there, because we know adding the ones first is so much easier because we can easily regroup flawlessly. But we need our students to understand, and that's where the shift in these exams has really shifted over the past year or two. I'm glad that you understand. The shift in mathematics has really shifted on these exams recently to not just solving problems, but understanding the why behind it. So while you and I learned, and often we teach students, that it's easiest to add the ones first by allowing them to explore and add using models and concretely first, and then they might add the hundreds first, is okay. It makes us cringe inside because that's not how we learned sometimes. However, once we realize the power and what that looks like, it makes a world of difference in the classroom. Okay, that's my soapbox. I'm done with my primary math soapbox. But that said, B is definitely the trick answer, and that is the answer I would expect most people to pick. So anyways, yes, mathematically, it's not wrong, but it's not efficient either. So if it asked what the most efficient way to solve this problem is, it would be to add the ones first. And I wouldn't put it past the test writers to ask that question. So we could see this written two different ways. All right, student error analysis, check. A lot of people asked for that, and I will definitely try to include that each week because I know that that's a huge part of the exams now. All right, this is another student error analysis, but it's a high school example. So a teacher asked students, and I'm going to have to go to this view so that you can see the entire problem. A teacher asked students to write observations they notice about the table modeling a quadratic function, represented by the table of values below. Some students wrote down accurate observations about the quadratic function represented in the following table. Which of the following student explanations provide evidence of a mathematically valid strategy? Select all that apply. Now, I do want you to also note that selecting all that apply was another very popular thing that people wanted to see out of tonight. People wanted to see that select all. So, which of the following student explanations provide evidence of a mathematically strong or valid strategy? So let's go ahead and look at this. The first thing I'm going to do, like I said, when I'm looking at student error analysis problems, is not go to the answer choices and try to figure it out. It's going to be to kind of figure it out on my own and then go to it, unless I can read through and realize there's some outliers. So let's look at this and see if we can find some outliers first. I know there's only one x-intercept because the x-intercept is the value represented when y is equal to 0. All right, there is only one value in this table that shows y equaling 0. And someone in here asked for an XY table with values. I want you to understand that just because what we are looking for is not in the table, that does not mean it doesn't exist. If this is a quadratic function, it's going to be more than 4 points. Just like if it was a linear function, it would be more than 4 points. So I'm going to put a question mark next to that because it's not wrong off the bat, but it's not right off the bat either. I know the quadratic function is an up-facing parabola, meaning that the value of a has to be positive when I write the equation because the values of x are increasing. Just because the values of x are increasing does not mean that it's an up-facing parabola. Let me give you an example. That is a down-facing parabola, but I could list the x values 1, 2, and 3, and the x values would be increasing while the y values are decreasing. So that is not a mathematically strong, valid strategy. For this function, I notice that as the values of x increase, the values of y increase and then begin to decrease, showing that it has a negative value of a. Let's think about that again. As x increases, the values of y increase, and then begin to decrease. Does that create a mathematically valid strategy? Absolutely. In fact, that addresses some of the key features of a parabola, where the interval of the parabola is increasing and decreasing. So as the x values are going up, the y values increase to a certain point and then they decrease. So C is correct. D, I know that the value of A is going to be 1 because the relationship between the vertex and the 2 points, 1 unit to the right and 1 unit to the left of the vertex, are both 1 unit vertically away from the vertex. That's a lot to handle. So let's take a look at what that means. First, I need to figure out which of these values is the vertex. So let's go ahead and graph this. So I'm going to draw my tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. So over 2 up 0. Over 3 up 3. Over 4 up 4. Over 5 up 3. And there you have it. Where's our vertex? 4, 4. So let's read that example again. I know that the A value is going to be 1. So that means when we write our equation, f of x equals ax squared plus bx plus c, I know that the A value, it could also be f of x equals ax minus h squared plus k, is going to be 1, because the relationship between the vertex and the 2 points, 1 unit to the left of the vertex, 1 unit to the right of the vertex, are both 1 unit away vertically from the vertex. True or false? That's a difficult one. So Joseph, you say D is false. My initial gut was that D was true. So talk to me about why you think D is false. I was going to say D is true. Now, we know A is not true after drawing this, because this has to come back down and hit that x-axis again. The only time we are going to have one x-intercept is if it bounces and comes back up. So A is going to be false. Ah, okay. Yes, you are absolutely correct. Wow. I didn't even think about that. I'm so glad you said that. Okay, so I wanted to select all that apply, but you're absolutely right. This should be a -1, not a +1, but then everything else would be true. So I was going after the original function, f of x, the parent function, f of x equals x squared. Looks like this. A vertex at 0, 0, a point at 1, 1, and 2, 4. And then it comes down and up. So what happened with this parabola, it was shifted to the right, it was shifted up, and it was reflected over the x-axis, or it's upside down. We know it's upside down, which means that A has to be negative. So what I was going after was that when A equals 2, or A equals 1/3, what happens is it stretches or shrinks the parabola. So from the vertex, your first point that is 1 unit to the left and the right might only be a half up, or it might be like 3 up. But the fact that it's 1, 1 means that it's in the same proportion as the original function. But Joseph is absolutely correct. Because it is upside down, A would have to be equal to -1. Excellent, excellent point, Joseph. Now, let's take that same problem and find the quadratic function that's represented by that. So, select all that apply. Which of the following quadratic functions is represented correctly by this table of values? Elementary people, I promise there's more for you later. Give me a second. So when I look at these, I know for a fact that I'm not going to have 4 answers. Why? Because I'm not going to have 2 answers that are standard form that are totally different. And I'm not going to have 2 answers that are vertex form that are totally different. So with that said, let's take a look at this and figure out what key features we can figure out. So if I didn't have this previous problem, what I would do is I would graph it like we just did. And I'm actually just going to copy and paste it from here so that we don't have to do that all over again. Copy, paste. I love the copy paste feature. And I'm going to erase some of this extra stuff that we have going on. So here's my parabola. Here's what I graphed. I know I have, and I'm going to do a quick list of what I know. I know it's upside down. which means there needs to be a negative out front. I know that A equals a -1 and nothing more, nothing less, because of that relationship between the vertex and the next 2 points. I know that my x-intercepts are 2, 0. I also know that my other x-intercept is going to be 6, 0, because the vertex is going to be exactly in the middle. And so I know that my other x-intercept is going to be symmetrical to the other side because of the way this parabola is built. So when I look at these, oh, and I know my vertex is 4, 4. So I know one of these is in vertex form. So if it's in vertex form, I know f of x equals x minus h squared plus k is vertex form. So if my vertex is 4, 4, and I plop those in right here, I know that C has to be one of my answer choices because it's going to be x minus 4. That's what I need you to understand, is that the x value of the vertex in vertex form is opposite of the sign that it actually is. Okay? So I know x minus 4 squared plus 4 is going to be my vertex form. I know A equals -1, and there's my negative, which means D is out. Then from there, you can just factor it to figure out what standard form you're looking at. So I'm going to have x minus 4 times x minus 4 plus 4. So I have x squared minus 4x minus 4x plus 16 plus 4. X squared minus 8x plus 16 plus 4. Distribute that negative. Negative x squared plus 8x minus 16 plus 4. This becomes a 12, so negative x squared plus 8x minus 12. None of those are the case. So in this case, there is not a select all that apply. I'm going to be quite frank with you. My intention was to have a select all that apply that works. So yeah, there's that. My intention was absolutely to have 2 answers in this too. Listen, I'm not used to creating select all that apply, so I feel like my brain is like, no, there can't be more than one answer. My goal was to have more than one answer in this case, but I didn't make more than one answer, so C is the right answer. But that process was important for you to recognize, right? And if, okay, let's do a little problem solving. If there was going to be more than one answer, it certainly wasn't going to be A, because A doesn't have a negative value showing that upside down parabola, right? All right, let's keep going. Hey, y'all, I don't want to jinx it, but I said that my bet was that my iPad would only last until 6:26 without disconnecting, and it's 6:29. Crazy. All right, let's keep going. Somebody specifically asked for inequalities. So I am going to go ahead and solve this inequality problem. Hey, look, it's a select all that apply. Let's see if there's actually more than one answer this time. Which of the following satisfies the inequality below and makes it true? Select all that apply. Joseph, I love the hand clap. I wish you were here to give me a fist bump and a hug. I love that. All right. Here's a little tip. If this intimidates you, don't solve it. Take your answer choices and plug them in one at a time. Now, I will say, I usually, when I'm plugging in answer choices, will start with C or D, and then I'll go vertically depending on how my answer panned out. Because if I start here and then I keep working my way down, sometimes it's a lot more work. But if I start in the middle and work my way up, then it works out a little bit better, or work my way down. I'm a very algebraic thinker. So I'm going to go ahead and solve this algebraically, but then I will show you how to solve it by plugging in answer choices. So let's take this and solve it. 4x negative plus 13 is less than 28 minus x. In order to solve this equation, we need to get all the x's together. So I'm going to add x to both sides. And that gives me negative 3x plus 13 is less than 28. Now I'm going to subtract 13 from both sides. Negative 3x is less than 15. Now I'm going to divide both sides by negative 3. And an alarm is going off in my head. Woo, woo, woo. Because anytime you multiply or divide by a negative value on both sides in an inequality, you must flip the sign. This is critical. So my symbol is going to flip, giving me negative 5. Now, which of these values satisfies x is greater than negative 5? Which of these values satisfies x is greater than negative 5? Well, 5 is greater than negative 5. 0 is greater than negative 5. Is negative 5 greater than negative 5? No, and these answer choices are in numerical order, so I know A, B, and C are all out. Now, if it was x is greater than or equal to negative 5, then this would have been correct. But because it's not, that's not a correct answer. Now, let me show you how I would solve this not using that method. I'm going to use the plug it in method. For those of you who are intimidated or struggle with that algebraic way, using your answer choices to your benefit is a huge piece of this. So negative 4, I'm going to start dead in the middle, times negative 5 plus 13 is less than 28 minus negative 5. Now that is where people are going to make a mistake. A negative times a negative. This is going to equal 20, positive 20, because a negative times a negative equals a positive, is less than 28. Negative times a negative is a positive, plus 5. 33 is less than 33. True or false? False. So I know that's not an answer. I'm going to move to 0. For no other reason than plugging in 0 is a lot easier than plugging in negative 8. I could have gone in either direction, but plugging in 0 is a lot easier than plugging in negative 8. So negative 4 times 0 plus 13 is less than 28 minus 0. 13 is less than 28. True or false? True. That right there gave me everything I needed to know, because I knew that negative 5 was not a choice, but I knew that 0 worked, which means anything bigger than 0 is also going to work. And anything smaller than negative 5 is not going to work. So D and E are our answers. All right, let's keep going. Jonathan wants to use an XY table to create a linear equation. Which of the following tables should he use? So this was specifically requested by somebody, I don't remember who it was, but somebody specifically requested XY tables and Y equals MX plus B. Here it is, XY tables and linear equations, which is Y equals MX plus B. Which of the following tables should he use? So I noticed something about all of these tables. They all have the same X values represented in the table. There are two different ways we can do this. If you are really savvy and you really understand linear equations, you might be able to look at this and be like, got it. I know the answer. The answer is blah, blah, blah. Because you understand patterns and how linear patterns work. However, if you are not that person, you can do one of two things. You can attempt to write an equation for the linear equation, or you can do quick graphs. Let's do some quick graphs. So, A. One, two, three. 1, 2, 3. And I'm just going to copy that so that I can duplicate it over and over and over. Okay. -1 up 2. -1 up 2. Over 0 up 4. Over 1 up 8. Over 2 up 16. Okay, that kind of looks like a line. I'm going to keep going. -1 up 2. Over 0 up 4. Over 1 up 8. -1, -2. That is definitely not a linear function because I have the same X value with different Y values. So that's out. -1 up 2. 0, 0. Over 1 up 2. I don't even need to graph the other one because that does not create a line. -1 up 2. Over 0 up 4. Over 1 up 6. Over 2 up 8. Out of A and D, which one looks more like a linear equation? D definitely looks more like a linear equation. However, we certainly don't want to be taking this test using looks. We want to use it we want to take it by using mathematical reasoning. So here's why it's D and not A. When we are looking at a linear function, we want to look for a consistent slope, which means it's rising and running by the same exact amount every single time. So when we're looking at a table of values, sometimes they will try to trick you. They might give you something like this. XY, -1, 0, 1, 4. 2, 4, 6, 12. That is still linear because even though they skipped 2 and 3, it's increasing by the same amount every time. And if I had number 2, it would be 8. And if I had number 3, it would be 10. And 4 is 12. So it still follows that same pattern. However, when we are looking at a pattern that is multiplying and not adding, that tells me we're looking at some sort of exponential function. It tells me we are not operating with a linear function. So if we are increasing by the same amount every time using addition, and we're not increasing exponentially by using multiplication, then we are golden. We have a solid, consistent slope. But this is not what we're looking for. This would be considered exponential, and this would be considered absolute value. And this is just nothing. B is nothing. Now, I did a very similar thing with problem 5 as I did with problem 2 and 3, where I had us look at the problem, but then I had us actually develop the equation. We're going to do that same thing for problem 5. Jonathan wants to use the same table that we were looking at to create a linear equation. Which of the following equations represents the linear equation as represented by this table? So I'm going to look at my answer choices first, because what I want to do when I'm looking at my answer choices is determine, did they use slope-intercept form? Did they use point-slope form? What did they use to determine the answer choices? And when I look at all my answer choices, they are either in standard form or they are in slope-intercept form. So I'm going to try to figure out how I can get my equation in slope-intercept form and then turn it into standard form. So in slope-intercept form, what do I need? Mathematicians are not very creative. So I need a slope and I need an intercept, specifically a y-intercept. So when I look at this table of values, this XY table of values, I immediately see my y-intercept. Because it's when X is 0. So I know I'm going to have y equals mx plus b. So already I know D is not an answer, because in slope-intercept form, my intercept is +4, not -4. So what is my slope? Well, we know that slope equals rise over run, or the difference in my y's over the difference in my x's. Now, you might be thinking to yourself, yeah, but Amy, I've always seen it with little 2's and little 1's. Yeah, but why memorize extra stuff when you don't have to? The little 2's and the little 1's literally just mean if you do the y value first of one point, you have to do that x value first in that point when you subtract. So I'm going to pick 2 points, any 2 points, because remember, in a line, slope is the same no matter what 2 points you choose. So I'm going to pick these 2 points, but you might pick these 2 points, or you might pick these 2 points, or you might even pick these 2 points. It's not going to matter. So I'm going to do y minus y. Because I did the 4 first, I have to do the 0 first, over x minus x. 4 minus 6 is -2. 0 minus 1 is -1. And a negative divided by a negative is a positive. So y equals 2x plus 4. C is not the answer. Now, I'm going to put it into standard form and see where we go. So I'm going to subtract 2x from both sides. And I get -2x plus y equals 4. If I multiply everything by a negative value so that my negative 2x turns into a positive 2x, I'm going to get 2x minus y equals negative 4, which tells me A is not the answer, which is why B is the answer. Now you're like, why is B the answer? It's a great question. Let's cross-check this. So I have 2x minus y equals negative. In order to check myself, I'm going to multiply this by a value. This is a 6. How do I get the 2 to be a 6? Well, I multiply by 3. Let's see if we get this answer by doing that. 3 times 2 is 6x. 3 times negative y is negative 3y. And 3 times 4 equals negative 12. Bingo. What did I do? Negative 2x plus y equals 4. What do you mean? How did I get that? I had my y equals mx plus b, which was y equals 2x plus 4. And then all I did was subtract the 2x from both sides. And so I got negative 2x plus y equals 4. Does that make sense? So I took my slope-intercept form and then I started to put it into standard form. Does that make sense? That was a really good question. All right, any questions about this? All right. Okay, I promised we would do this fraction problem last week. I will come back to this problem next week. We are not going to have time to go over this problem this week. And I've done a ton of high school, middle school stuff. So I want to get to another elementary question. But I promise this will be next week. So if 5/8 x plus 7 equals 26, and 2/3 times x plus y minus 4 equals 32 are both true, what is the value of y? So my high school people might be looking at this problem thinking, oh my gosh, this is totally like elimination. But really it's not, because this problem only has an x value. So really what I can do is solve the first equation for x and then plug x in to the other equation. So 5/8 x plus 7 equals 26. I'm going to subtract 7 from both sides. So 5/8 x equals 19. Now, how do I undo what's being done? I can divide by 5/8 on both sides because technically x is being multiplied by 5/8. However, I can also multiply by the reciprocal, because by multiplying by the reciprocal, I can cancel out that fraction, because 8 times 5 is 40, and 5 times 8 is 40, and 40 divided by 40 equals 1. So this whole thing equals 1. X equals 19 times 8 over 5. Now, if I'm looking at 19 times 8 over 5, when I look at multiplying fractions, now, elementary people, this process of solving this problem may not be for you, but you got to understand how to multiply, divide, add, and subtract fractions. So, how do I multiply a whole number times a fraction? Put the whole number over 1 and multiply straight across. So 19 times 8 equals 152 over 5 times 1 is 5. Now, I'm going to plug that x value in here. So 2/3 x plus y minus 4 equals 32. I'm going to go ahead and add 4 to both sides. So I have 2/3 times 152 over 5 plus y equals 36. Now I have to do one of two things. I can either distribute this through, or quite frankly, I can get rid of it right now. I'm going to choose to get rid of it right now because I don't want to distribute the 2/3 all the way through. So I'm going to multiply by 3/2 on both sides. 152 over 5 plus y equals. Now, I can multiply straight across and then simplify. Or I can simplify on the front end of this problem. I know that I can divide 36 by 2. So rather than end up with a larger answer, I'm going to go ahead and simplify that early and then multiply by 3. So that's all going to equal 54. Subtract 152 fifths. So y is going to equal, now how do I do 54 minus 152 over 5? What do I need to do? I need to get common denominators. So in order to get this to have a denominator of 5, I need to multiply by a value of 1. Because by multiplying by a value of 1, I'm not changing the core value of that number. So 54 times 5 is 270 over 5 minus 152 over 5. 270 minus 152 equals 118 fifths. Why didn't I subtract that? Because when we add and subtract fractions, we do not touch our denominators. So C is the correct answer. We are going to stop there for today. I promise we will get to this problem next week and this problem next week. Y'all, my iPad never disconnected. How amazing is that? I literally can't believe it. That never, ever, ever happens. So I consider that a win. All right. What do you want to see me go over next week? I'm going to add it to my handy dandy notes page. What do you want to see me? God, Joseph, I love that you noticed that too. That just made my day. What do you want to see me go over next week? Let me know in the comments. I'm getting ready to sign off. However, let me know in the comments what you want to see me go over next week. I'm going to turn it back over to Dr. A. I will be monitoring the comments for the next few minutes. And I can't wait to see you next week. So let me know in the comments what you want to see. If I don't get a lot of comments, I'll just come up with a whole bunch of great problems. So with that said, thanks for spending your Wednesday with me. And I will see you next week. Statistics and probability. I will add that. Statistics and probability. What are you studying for? Probability. Are you studying for GK, elementary, middle school, high school? What are you studying for? That's going to help me kind of guide that. All right, turning it back over to Dr. A, and I will monitor these comments. See y'all.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.